Hello students, good morning. Today we will see the comparison between ground wave propagation, sky wave propagation and space wave propagation. Up to this lecture we have seen the explanation for ground wave propagation, sky wave propagation and space wave propagation. Today we will see the comparison of ground wave propagation, sky wave propagation and space wave propagation. It is very important point as you are considering the MSBT exam. Okay, there is a question as compare ground wave propagation and sky wave propagation, or compare sky wave propagation and space wave propagation, or compare ground wave propagation and space wave propagation. So we will see the comparison for this three type of propagation. So first one it is the ground wave propagation, next one it is the sky wave propagation, and next one it is the space wave propagation. So first point it is the frequency range. Okay, the frequency range for the ground wave propagation, it is the 30 kilohertz to 3 megahertz. The frequency range for the ground wave propagation is 30 kilohertz to 3 megahertz. Okay, frequency range for the sky wave propagation, it is the 3 megahertz to 30 megahertz. Okay, frequency range for the sky wave propagation is 3 megahertz to 30 megahertz. And last one it is the space wave propagation. For this space wave propagation, frequency range is above 30 megahertz. It is the above 30 megahertz. Okay. Next point it is the application. Okay, application of ground wave propagation is AM radio broadcasting. Application it is the AM radio broadcasting. Next one it is the sky wave propagation. The sky wave propagation, which is also used for the radio broadcasting, but it is used for the short wave frequency range, and ground wave propagation, which is used for the medium frequency range. Okay, medium wave frequency range. Last one it is the space wave propagation. The space wave propagation, which is used for the TV and FM broadcasting. Okay, this space wave propagation, which is used for the TV and FM broadcasting. Again, FM, which is nothing but your radio broadcasting. All type of propagation which is used for the radio broadcasting, and space wave propagation, which is used for the TV broadcasting also. Okay. Next one it is the polarization. Okay. So the ground wave propagation, which is vertically polarized, sky wave propagation, which is also vertically polarized, and space wave propagation, which is horizontally polarized. The ground wave propagation, which is vertically polarized, sky wave propagation, which is also vertically polarized, and space wave propagation, which is horizontally polarized. Okay. Next point it is the transmission path. Next point it is the transmission path. Okay, ground wave tilt progressively and eventually die. This limits the range of communication. Okay, this limits range of communication. Okay, for the sky wave propagation, the transmission path, it is limited by the skip distance and curvature of earth. Okay, next one, for the space wave propagation, the transmission path is limited by the line of sight and radio horizon. The transmission path, which is limited by line of sight and radio horizon. Next one it is the principle. Okay, so principle for ground wave propagation is ground waves are surface waves which travel along the surface of earth. Ground waves are surface waves which travels along the surface of earth. Okay, principle for this sky wave propagation is sky waves are reflected from the ionosphere. This is how communication takes place. Okay, and principle for this space wave propagation is Space wave travels in a straight line from transmitter to receiver through space. Next one, it is the service range. Okay, service range for the ground wave propagation, it is the few hundred kilometer. Service range for the sky wave propagation, it is the few thousand kilometer. And service range for the space wave propagation, which is not more than 100 kilometer, which is not more than 100 kilometer. Next one, it is the power loss. Okay, so power loss for the ground wave propagation takes place due to the absorption by ground and due to tilting of wave. Okay, next one, for sky wave propagation, power loss due to the absorption of energy by the layer of ionosphere. And for space wave, power loss due to the power absorption and scattering by the tall and massive objects. Okay, next one, it is the problem of fading. Okay, the problem of fading is not very severe for the ground wave propagation. The problem of fading is not very severe for the ground wave propagation. Problem of fading which is severe for the sky wave propagation, which is severe for the sky wave propagation. And for space wave propagation, fading is not severe. The fading which is not severe for the space wave propagation, but shadow zone due to tall object and ghost interference are serious problem. Okay, so fading which is only severe for the sky wave propagation. Next one, it is the application of ground wave propagation. It is the medium wave band radio broadcasting. Okay, for sky wave, it is the short wave band radio broadcasting. And for space wave, it is used for the TV transmission, FM transmission and satellite communication. It is used for the TV transmission, FM transmission, satellite communication. Okay, next one, it is the limitation for the ground wave propagation. The limitation is limited range and tall antennas are required. High transmission power which is required for the ground wave propagation. For sky wave propagation, skip distance power loss due to absorption of energy by that layer. And for space wave, distance is limited, fading which is takes place due to the rain and fog. Okay, so this is the comparison of ground wave propagation, sky wave propagation and space wave propagation. So first point, it is the frequency range. So frequency range, it is the 30 kilohertz to 3 megahertz for the sky wave, 3 megahertz to 30 megahertz, and for space wave which is above 30 megahertz. Okay, so ground waves are vertically polarized, sky waves are also vertically polarized, and space waves are horizontally polarized. Service range for the ground wave propagation, which is the few hundred kilometer. Service range for the sky wave propagation, it is the few thousand kilometer, and for the space wave which is not more than 100 kilometer. So next one, it is the problem of fading which is not severe for the ground wave propagation. It is the severe for the sky wave propagation, and problem of fading which is not severe for the space wave propagation. Application of ground wave propagation, it is used in medium wave band radio broadcasting, sky wave which is used in a short wave band radio broadcasting, and space wave which is used for the TV transmission and FM transmission and satellite communication. Okay, So these are the important point for the ground wave propagation, sky wave propagation and space wave propagation. So next one, it is the duct wave propagation. This duct wave propagation, which is also called as a super refraction. The duct wave propagation, which is also called as a super refraction. Okay, this duct wave propagation, which is used for the microwave frequencies. Okay, this duct wave propagation, which is used for the microwave frequencies. Okay, so this duct wave propagation, which is consist a special phenomena which is called as a super refraction or ducting. Okay, this type of propagation which is used for the very high microwave frequencies. Okay, so figure which is shows the duct wave propagation. So top of the duct, which is shown in figure, earth surface and top of the duct. In between this earth surface and top of the duct, there is a atmospheric duct which is formed. Okay. So general phenomena, it is the as your height which is increases, then air density which is decreases. So refractive index which is increases. Okay, as your height which is increases, your above the earth surface, the air density which is decreases and refractive index which is increases. Okay, but because of some atmospheric condition, okay, when your warm air which is trapped above the cold air, then as your height which is increases, refractive index which is decreases rapidly. Okay, due to the reduction, microwave frequencies are completely bent back to the earth. Okay, the signals are reflected from duct to earth and from earth to duct. Okay, so this duct wave propagation, which is used for the 1000 kilometer, maximum 1000 kilometer. Okay, so this duct wave propagation, which is used for the very high microwave frequencies. Okay, it consists of special phenomena is called as a super refraction or it is called as a ducting. Okay, so the general phenomena, it is the as your height which is increases, your air density which is decreases and refractive index which is increases. But because of some atmospheric condition, when warm air which is get trapped above cold air, at that time as your height which is increases, then refractive index decreases rapidly. Okay, due to this reduction of refractive index, the microwave frequencies are completely bent back to the earth. Okay, the signals are reflected from duct to earth and from earth to duct. Okay, this duct wave propagation, which is used for the distance up to the 1000 kilometer, or it is the service range, it is the 1000 kilometer. Okay, I repeat once again, duct wave propagation, we have to write all these points in a MSBT exam. Okay, so this duct wave propagation, which is also called as a super reflection. Okay, this type of propagation which is used for the microwave frequency, which are neither reflected by ionosphere nor propagates along the earth surface. Okay, next one, the general concept, it is the as your height which is increases, air density which is decreases and the refractive index which is increases. But under certain atmospheric condition, when warm air which may get trapped above cooler air, this condition which is happen above the earth above the surface of water. Okay, due to this condition, the refractive index which is decreases rapidly. As your height which is increases, the refractive index which is decreases rapidly. Okay, due to this rapid reduction of refractive index, your microwaves are completely bent back towards the earth surface. Okay, due to this rapid reduction of refractive index, microwaves are completely bent back towards the earth surface. Okay, thus microwaves are continuously reflected inside the duct and reflected back by the ground or water surface. Okay, the region in which super refraction takes place is called as a duct. The region in which super reflection which is takes place, it is called as a duct. The microwaves are continuously reflected inside the duct and reflected back by the ground or water surface. The region in which super refraction which is takes place is called as a duct. Okay, the duct can be formed near the earth surface or at some height from it. Okay, the ducts can be formed near the earth surface or at some height from it. Okay, this type of propagation which is used for the high frequencies which are in a gigahertz range. Okay, this type of propagation which is used for the high frequencies which are in a gigahertz range. Okay, so this duct wave propagation which is used for maximum distance of 1000 kilometer. Okay, this duct wave propagation which is used for the maximum distance of 1000 kilometer. So it is the very easy concept. So you have to write all these points in a MSBT exam. Next one, it is the single and multipath duct wave propagation. Okay, so first question, it is the why we are using the multipath propagation. So to increase the distance, we are using the multipath propagation. Okay, so this multipath propagation is a term which describes the multiple path. Okay, a signal travels to reach the destination. Okay, so signal are using multiple path to reach the destination. Okay, this path includes a number of hops. Okay, the paths may be the result of reflection, refraction, or even diffraction. Okay, and finally when the signal from such a different paths gets to the receiver, it carries propagation delay, additional noise, phase difference, etc. Okay, which decreases the quality of the received output signal. Okay, so first we see what is the single path duct wave propagation or single hop duct wave propagation. In this single path duct wave propagation, only single path which is used to reach the destination. Okay, to reach the destination. And second one, it is the multipath duct wave propagation. This multipath duct wave propagation which are using many paths to reach the destination. So this is the multipath duct wave propagation. This multipath duct wave propagation which is uses multiple path to reach the destination. Okay, so today we have seen the comparison of ground wave propagation, sky wave propagation and space wave propagation. Next we have seen the duct wave propagation, its diagram and explanation. And next we have seen the single and multipath duct wave propagation. So today we stop here, and from tomorrow's lecture we see the tropospheric scatter wave propagation. This is the last point of your wave propagation chapter. So thank you. On next lecture we will see the tropospheric scatter wave propagation and MSBT question. We will discuss in a next lecture. So thank you.